So it is better to leave it to you. Okay. Now I bring this concave lens and convex lens both, so you can see this. I think it is visible to everyone. This is convex lens. You can see that both the way I will show you. This is convex lens. And how can you identify a convex lens? When we touch the middle and the edge, if the middle is thicker compared to the edge, so that means it is a convex lens. Got it? If this is the way to identify concave lens and convex lens. So first of all, let us see how to identify a convex lens. So when we touch convex lens, it is thick at the center and it is thin at the edge. Got it? Even you can write it down. Mehek.
Ma'am, your video is not on.
Okay, my video is not on.
Ma'am,
My video is on only, Mehek. Saurabh, my
Yes,
video is
ma'am.
on or off?
Ma'am, it's on.
On. Correct. Because maybe some network issue is there. Am I audible? Am I audible?
Yes, ma'am.
Okay. So this is the lens known under the name convex lens. So you can mention that point. Which point? It is thicker at the center than the edge. So edge is little thin compared to the center. So this is the way we can identify a convex lens. Now I will show you a concave lens. Okay, it is just opposite. This is, see, you can see that. Have you seen? See, this is a concave lens. How to identify? Look at the edge. Now I am showing the edge. I think it is visible to everyone. Edge is thicker as compared to the center. Edge is thicker, is thick compared to the center. So you can mention this point also. Concave lens. Edge is thicker than center. So this is the way, without performing any experiment, we can identify a convex lens from a concave lens. Okay, so this is all about the introduction part that we are discussing. Then we are discussing refraction of light. Refraction means bending of a ray of light when it passes from one medium to another medium. So what is the reason behind this bending of light, or what is the cause of refraction? The cause of refraction is due to the difference in speed of light in different media. So when we compare different media, the speed of light is different in different media. So we know that speed of light is maximum in air and it is less in water, still it is less in glass. So when light passes through a different medium, like from air to glass or air to water, naturally the speed of light changes. This resulting a phenomenon called a refraction. This we have seen. And second point regarding refraction is when the light rays passing through a glass, rectangular glass prism, so it is the light undergo refraction twice. How it undergo refraction twice? First of all, when light moving from air to glass, there is one refraction takes place. Then after that, it passes through the glass, and when it comes out, that ray is called emergent ray, and the angle of that angle which is formed by the emergent ray with normal is called the angle of emergence. And during this emerging process, it again undergoes second refraction. So when a ray of light passing through a glass prism, it undergoes refraction twice. This also we have seen. And last class we have seen how to get images of a spherical lens, different lens. Or before doing that topic, in detail, let us think about one important topic related to refraction, and that is called laws of refraction. You can mention in your copy. Laws of refraction. What is laws of refraction? There are two statements for laws of refraction, and the first one is the incident ray, the refracted ray, and the normal. These all lie in the same plane. Okay, this is similar to that of laws of reflection. There is a difference in the second part, so that we will see. First, let us think about the first statement, first part. The incident ray, the refracted ray, and the normal to the interface of two transparent medium. What do you mean by interface of two transparent medium? Interface means, suppose this is the phase at which there is change in medium takes place. So this particular phase at the junction of two media. So this is called the interface. Interface of two transparent medium at the point of incidence are lying in the same plane. So this is the first. If you want the statement, I will give you. Wait for 1 minute. Now let us think about the second part. Second part of the law is the ratio between angle of incidence to the angle of refraction is always a constant for a given color of light and for a given media, given pair of media. So what is a constant? The sine of angle of incidence. Sine, in 9th class we have done algebraic relations and all. So there you have seen sine, cos theta, sine theta and all. So, or sine, cos, tan, these all you have heard at least. So the ratio between sine of angle of incidence, I will write it down, sine of angle of incidence divided by sine of angle of refraction. It is a constant. This is the second part of the law. What is the second part? Ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of medium. This second part of the law is also known under the name Snell's law. Snell's law. Okay, Snell's law is actually second part of laws of refraction. Okay, what is Snell's law? Suppose the question is, what is Snell's law? So how to answer that Snell's law? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given light, for a given color and for a given pair of medium. So this law is called the Snell's law of refraction. So this is known under the name laws of refraction. I think it is clear to you. First part, incident ray, reflected ray and normal. At the point of incidence, these are lying in the same plane. Second is, it is the definition of the constant. Which constant? Ratio of sine of angle of incidence to sine of angle of refraction is a constant for a given light and for a given color and for a given pair of medium. So this is all about the laws of refraction. Okay. Now later sine and all, it is very difficult to calculate sine and all. So the constant which is formed. It is known under the name refractive index. It is called the refractive index. So refractive index is simply, it is the ratio of sine of angle of incidence to sine of angle of refraction. When you come to the higher class, especially 12th class, we have again the topic optics. So there you have to work out with all these formula and numerical and all. Okay, now you understood this much. Refractive index is a ratio of sine of angle of incidence to sine of angle of refraction. Okay, now if sine value is not there, otherwise also the refractive index is significant. Why is it significant? It conveys one important quantity, physical quantity of light. Which physical quantity? It is related to velocity of light. The extent of change in the direction of light when it passes from one medium to another medium. It is simply given by refractive index. Understood? The extent of change in direction of light. So we have already seen when the speed of light is different in different medium. So when light moves from one medium to another, two processes will be takes place. Either the speed will increase or the speed will decrease. How far are the extent to which the deviation in the direction takes place? This is simply conveyed by the value of refractive index. Okay, so it is connected to relative speed of propagation of light between two mediums. It is relative. Relative means what? It is not permanent. It is a relative quantity. Refractive index is a relative quantity. Why is it a relative quantity? So suppose a ray of light is moving from air to glass. There, light is coming from a rarer medium to a denser medium. And in other way, if light is passes or moving from glass to air, there the refractive index is different because glass is a denser medium and air is a rarer medium, and here light is moving from denser medium to rarer medium. Got it? This is the difference. So we can say that refractive index is not a permanent quantity. It is a relative quantity. Relative means one with respect to other, how much it is. So this is the significance of refractive index. If you want to calculate refractive index for a given pair of medium, it is simply calculated by using the speed of light. Speed of light in air to speed of light in a particular medium. And it has no unit. Refractive index has no unit because it is a ratio. Moreover, it is a relative quantity. That's why it has no unit. Then there is one more term related to refractive index. It is called the absolute refractive index. Absolute. It is very simple. In the case of absolute refractive index, one medium is fixed. Which medium is fixed? It is either air or vacuum. One of the medium must be either air or vacuum. The other medium may be different. Which are the different media? Glass, water, diamond, any other medium. So if you want to calculate absolute refractive index, how to calculate speed of light in air or speed of light in vacuum to speed of light in that particular medium. So this value is called the absolute refractive index. But we are not supposed to use any symbol. You simply write it down. I will write the formula on board. You try to note it down. Okay. Suppose refractive index is represented by the letter. This is the letter used to represent medium. Absolute refractive index. Absolute. absolute refractive index of a medium, it is the ratio of speed of light in air divided by so in the case of absolute refractive index, first medium is fixed. Which medium is fixed? Air is fixed. And which medium can change? If you want to calculate refractive index of glass, so here you have to substitute the value of speed of light in glass. If you want to calculate refractive index of water, so which is changing denominator has changed. Speed of light in water and the numerator remains same. There is no change. This kind of refractive index is known under the name what? Absolute refractive index. So the simple refractive index means medium is not fixed. But we can air and vacuum speed of light is almost the same, but we can't say that it is almost the same because you know that what is the difference between vacuum and air? Vacuum means that nothing is there. Air means what? Air has so many gases. Besides that, it contains water vapor, it contains some other particles and all. It makes the speed of light less as compared to that in vacuum. So there is a slight difference in speed of light in air. So, but when we are calculating it numerical and all, here either we can substitute speed of light in air or vacuum and the value is fixed. What is speed of light in air? You know the value 3 into 10 to the power 8 meter per seconds. This value remains constant and it never changes. So we can use this value for calculating refractive index of a particular medium. Got it? So then another example I will give. Suppose refractive index of water. So here I will write like this W. Suppose it is equal to 1.3. This is the refractive index of water. So what do you mean by this? The ratio of speed of light in air and the speed of light in water is equal to 1.33. So here speed of light in air divided by speed of light in water and it is equal to the value 1.33. This is the meaning of simple refractive index, absolute refractive index. Okay. I think this part is clear to you. So this segment we have discussed two important points. One is laws of refraction and second laws of refraction, two parts are there. The second part is known under the name Snell's law and second point is refractive index. Refractive index is the ratio of sine of angle of incidence to sine of angle of refraction and if you use it is simply connected to a physical quantity of light and that is called the speed of light and other ways also we can calculate refractive index speed of light in air to speed of light in a particular medium. So this is all about the first segment. Second segment I will show you diagrams which is related to convex lens and concave lens. Last class we have discussed some other points also. Some basic terms related to lens. Whatever be the type of lens, whether it is concave or convex, it is part of two different spheres. Yeah, correct. It is that constant is called the refractive index. Got it? Okay. So, sorry. So, basic terms related to lens, spherical lens. Whatever be the type of lens, convex or concave, it is a part of two different spheres. Because of that, we have two different focus for a lens, whether it is concave or convex. Okay, and the remaining terms are almost the same. Principal axis is the axis, or it is the line which is passing through two different focus, and center of curvature is there. Center of curvature means it is the point. You know that it is a part of the sphere only. So center of curvature is the center of the sphere from which this lens is made up of. So another point is, in the case of mirror, we have discussed the term pole. Pole means the center of the mirror. In this case, it is the terminology has changed, and in this case, it is optic center. And these are the major differences between mirror and lens. I hope it is clear to you. Now I am sharing my screen. So let us see. I think time is sufficient time we have now. Let us see that. I'm presenting. I'm sharing my screen. I hope the screen is visible to you. The screen has changed.
A lens is made up of a transparent medium such as glass or plastic that has at least one curved or spherical surface. A ray of light that passes through a lens is refracted once at each boundary first when it enters the lens, and once again as it exits the lens. The net result of this refraction is a change in the direction of the ray of light. There are two types of lenses: converging or convex lens and diverging or concave lens. The convex lens is thicker across the middle and thinner at the edges. The concave lens is thinner across the middle and thicker at the edges. A converging or convex lens converges rays of light that travel parallel to its principal axis. A diverging or concave lens diverges rays of light that travel parallel to its principal axis. A lens is made up of two curved surfaces, and each surface is a part of a separate sphere.
You can understand this particular point. See, in this figure it is already mentioned. You can see that it is visible. Convex lens is a part of two spheres. It is mentioned, and their center of curvatures are also mentioned. Center of curvature, that means the center point of first sphere is C1 and center point of second sphere is C2. Similarly, in the case of concave lens, both the spheres are there, both the spheres are connected, and C1 and C2 represent their center of curvatures. So this diagram illustrates the fact that whether it is concave or convex lens, it is a part of two different spheres. Okay.
Its surface will therefore have its own center of curvature. The principal axis is the line that joins the two centers of curvature of a lens.
If you want to write the definition, you can write the definition. Principal axis, what is principal axis of a lens? Principal axis is the line that joins two centers of curvature of a lens. Simply one sentence you can write in your copy. Okay.
The point within the lens on the principal axis, through which any ray entering the lens passes without deviation, is called the optical center. Because light can pass through either side of a lens, there are two focal points or principal foci located at equal distances from the optical center.
So in the book it is mentioned, instead of C1 and C2, in the book it is mentioned 2F1 and 2F2. And this is also correct and that one is also correct. Please note that this point. In the book, NCERT book, it is mentioned F1 and 2F1. That means focal length is distance between optical center and the focus, and 2F1 means it is double the focal length, double. So that means here C1 represent double focal length. That's why it is mentioned 2F1. Similarly, the other side of the lens, it is F2 and 2F2. So no need of any confusion. It convey the same message. Center of curvatures. Okay.
The distance between the optical center and the focal point is called the focal length. A ray of light parallel to the principal axis will pass through the second focal point after refraction through a convex lens. In the case of a concave lens, the ray of light appears to diverge from the second focal point.
So you need to draw this diagram in your copy. This is the diagrammatic representation of focus of a concave lens and convex lens. Okay, focal point and focal length. So from the diagram it is clear that in the case of convex lens, you can see that this is incident ray and it is coming, and here there is a change in the direction, and after the refraction it passes through a particular point, and this is the focus in the other side, not in the same. And in this case, actually, the refracted rays met at this good point. Therefore, convex lens is called a converging lens. In bracket, you can write convex lens is called a converging lens. Similarly, in the case of concave lens, rule is same. Ray of light, which is parallel to the principal axis after refraction, passing through the focus. But the difference is that in this case, the refracted ray appears to meet at a point, appears. It is not actually meet. It appears to meet at a point. And in fact, it appears to meet at the same side, focal point of the same side, not in the other side. Therefore, concave lens is also called a diverging lens. So these terms are important. Why convex lens is called a converging lens and concave lens is called a diverging lens. So how to answer the question? In simple way, you can say that in the case of convex lens, after refraction, the refracted rays actually meet at a point in the other side of the lens, and it is the focal point of the convex lens. Okay, and in the second case, in the case of concave lens, the refracted rays appears to meet at a particular point in the same side of the lens or the same side of incident radiations. So therefore, concave lens is also called a diverging. It appears to meet. That's why it is called a diverging lens. I hope it is clear to you. Let us continue.
You may have seen that prisms divert or refract light rays towards the direction of their bases. A lens may also be considered to be made up of a set of prisms and a solid glass block in the center. In a convex lens, the prisms have their bases towards the optical center. Hence, light rays converge to a point. In a concave lens, the prisms have their bases away from the optical center. Hence, light rays diverge as if they are coming from a point.
You can mention this point. Which point? A ray of light passing through the optical center of a thin lens will emerge without any deviation. Write it down. This is important. When a ray of light passing through the optical center of a thin lens, then it will be emerge without any deviation. It will not undergo any refraction. Okay.
The nature, position, and relative size of an image formed by a convex or concave lens is different for different positions of the object along the principal axis. Select the type of lens to begin the activity. Drag and place the object at different points on the principal axis and see the image formed.
So this is very interesting for you also. Image formation of a convex lens. You can see that first of all we are keeping the object beyond center of curvature. Beyond, you can see that here it is mentioned C1 or it is 2F1. Here this is the object AB. If in this case image is formed at which position, you can see that it is formed between F2 and 2F2, or it is between F2 and the center of curvature. Okay, what about this is the position? What about the nature of the image? What is the nature? You can see that it is inverted. It is inverted and it is real and inverted image. What about the size of the image?
Diminished.
Diminished. Very well, very good. Or simply you can say that it is smaller in size as compared to that of object. Okay, you can simply write only these points. You can write. After that, you can draw the diagram. These all diagrams are there in the book. Okay, but without understanding the image formation principle, maybe you can't draw the diagram. Okay, so this is the first position. Okay, got it? So you simply write position of the object and nature of the image, nature and position of the image. So the first position is it is beyond center of curvature, and the position of the image is between F2 and C2, and nature is real and inverted, and size of the image, it is smaller as compared to object, or it is diminished. Proper word is diminished. Okay. Now let us see the change in the image. Now I am keeping it at the center of curvature. Okay. Now see the image. So it's very simple. If the object is at the center of curvature or at 2f1, in the book it is mentioned 2f1, the image is formed at 2f2. Is it correct? Image is formed at 2f2 when we are doing it in proper way, the other side. Is it correct? You can write it down in your copy. Second case, where is the position? Let me clarify that position. The position of the object is at 2f1, correct? Correct. At 2f1 simply means at the center of curvature. You can see that image is formed at the center of curvature of the other side. Okay, what about the size? You can see, what about the size? Sachi, what about the size of the image?
Same as that of object.
Very good, beta, very good. And nature is, what about the nature? Saurav, what about the nature of the image?
Real and inverted.
सो रहे हैं क्या? हैं?
नहीं मैम,
अरे
मैम
थोड़ी
सर्दी
एनर्जी
जुकाम है ना
तभी
इसलिए।
ठीक नहीं है बेटा.
हाँ मैम।
ओह सॉरी, कोई बात नहीं, सुनो बस. It is real and inverted. Okay, so this is the way the image is formed, second position of the object. Now let us see when it is keep in between center of curvature and focus, then what will happen? See that. So when it is in between center of curvature and focus, look at that, image is there, and we can see the position. It is beyond center of curvature, beyond. Okay, and second is it is a highly magnified image, real and inverted, highly magnified. Now, what about at focus? If it is kept at the focus, what will happen? The image is formed at the infinity and it is highly magnified. Okay, when it is at focus, it is at infinity and it is highly magnified and it is real and inverted. Okay, now what happened when it is kept in between optical center and the focus? Look at that. If the object is at the optical in between optical center and the focus, so the image is formed at the same side, it is virtual and erect and it is highly magnified. So these are the different positions of convex lens. Now I am stop sharing and I am coming back to our class. Okay, so this is all about now this period's class related to this